Right now, 8.8 billion kilometers from Earth, a probe the size of a grand piano just detected something that shouldn't exist. It's measuring twice as much light in empty space as all the stars and galaxies combined can produce. Scientists are calling it the universe's hidden glow. But here's what will blow your mind. This discovery is coming from a spacecraft that was supposed to die 7 years ago. Instead, it's forcing us to rewrite physics textbooks. By the end of this video, you'll understand exactly how a mission designed for one quick photo of Pluto became humanity's most distant detective, solving mysteries we didn't even know existed. Let me put this in perspective. If Earth was a grain of sand, New Horizons would be 8.8 meters away. That's like trying to control a toy car at the end of your street using a TV remote. Every command takes 8 hours and 14 minutes to reach it. Every photo takes another 8 hours to return. We're literally communicating with yesterday. And here's the terrifying part. Its nuclear battery is dying. We have maybe 10 years left, possibly less. Right now, a team of just 40 people at Johns Hopkins Applied Physics Lab is racing against time. Because what New Horizons is discovering isn't just surprising, it's revealing that the universe itself might work differently than we thought. Today, we'll answer 3 mind-bending questions. How did a probe built to last 10 years survive almost 20? What is it seeing that has physicists questioning reality? And why might this dying spacecraft be humanity's most important explorer? Picture this. It's January 2006. NASA has spent $700 million on a spacecraft, and they have exactly 23 days to launch it. Not 24, not 22, exactly 23. Why? Because Pluto was literally running away. Every single day, it moved 4.7 million kilometers farther from the Sun. Its atmosphere, a thin veil of nitrogen, was about to freeze solid and crash to the surface like invisible snow. January 17th, first launch attempt. Category 3, hurricane winds, scrubbed. January 18th, second attempt. The entire launch complex loses power. A backup generator fails, scrubbed again. The mission director later said, "I aged 10 years in those 48 hours. Then, January 19th, the weather is marginal. One more delay means missing Pluto forever." At 2 p.m. Eastern, New Horizons doesn't just launch. It explodes off the pad at 1626 kilometers per second. To understand how insane this is, Apollo 11 took 3 days to reach the moon. New Horizons crossed the moon's orbit in 9 hours. That's like driving from New York to LA in 4 minutes. But even that ridiculous speed wasn't enough. A direct path to Pluto would take 14 years. Too long. The atmosphere would be gone. So they planned something audacious. Steal momentum from Jupiter. Imagine you're on roller skates and you grab a speeding train. When you let go, you're moving way faster than before. Same principle, but with planets. The catch? Jupiter is surrounded by radiation that makes Chernobyl look like a tanning bed. The radiation dose New Horizons would receive in one pass, equivalent to 10 million chest X-rays. They had to thread a needle, close enough to steal Jupiter's speed, far enough to not fry every circuit on board. February 28, 2007. New Horizons approaches Jupiter at 21 kilometers per second. And because scientists are opportunists, they turned every instrument on. Volcanic eruptions on Io, lightning in Jupiter's clouds, the birth of a new red spot. The gravity assist worked perfectly. New Horizons left Jupiter traveling 23 kilometers per second, shaving 3 years off the journey. Then, New Horizons did something unexpected. It went to sleep. Not dead, hibernating. Like a bear, but in space. Power consumption dropped from 200 watts to just 12. That's less than your Wi-Fi router. For 1,173 days, it drifted silently through the void. Once a year, they'd wake it up, check systems, then back to sleep. Mission Operations Manager Alice Bowman later told me, "My daughter was 8 when we launched. She was getting ready for college when we reached Pluto. I spent her entire childhood watching over a sleeping spacecraft." But in December 2014, everything changed. New Horizons woke up for the last time, and what it saw approaching made no sense. As New Horizons approached, mission scientists noticed something bizarre. a massive, bright region on Pluto's surface, shaped like a heart. Principal investigator Alan Stern's first reaction? That can't be right. Check the camera. Every model predicted Pluto would be a cosmic fossil, frozen solid for 4 billion years, dead as a doornail. Instead, they were seeing evidence of active geology. But here's what kept everyone up at night. They had exactly one chance. New Horizons would scream past Pluto at 14 kilometers per second. The entire encounter would last 24 hours, no do-overs. And with a 4.5-hour signal delay, they couldn't adjust anything in real time. Every photo, every measurement had to be pre-programmed months in advance. It's like trying to photograph a bullet with a camera you set up yesterday while blindfolded. July 14, 2015, the day humanity would finally meet Pluto. At 11:49 a.m., New Horizons turned away from Earth to face Pluto. For the next 22 hours, it would be completely silent, too busy taking photos to talk to us. Project manager Glenn Fountain described it. Imagine your kid going into surgery, and the doctor says, "See you in 22 hours." That's how it felt. 8:52 p.m. Eastern, the moment of truth. "We have telemetry." The room explodes. New Horizons survived, and then the images started arriving. Pluto's heart wasn't just a bright spot. It was a vast plain of nitrogen ice, 1,000 kilometers across, churning and flowing like a cosmic lava lamp. Mountains made of water ice, 3,500 meters tall. At Pluto's temperature, water ice is harder than granite on Earth. A blue atmosphere with 20 distinct haze layers, some reaching 200 kilometers high. But here's what broke every model. Parts of Pluto's surface had zero craters. None. That means they're younger than 10 million years. On a 4.6 billion-year-old world, that's like finding a newborn baby in a nursing home. Planetary scientist Kathy Olkin said, "We had to throw out the textbooks. Pluto wasn't just alive, it was more geologically active than Mars." But New Horizons was already leaving. At 14 kilometers per second, it couldn't slow down. The primary mission was over. Or was it? Here's something NASA didn't advertise. While New Horizons was sleeping its way to Pluto, they were secretly using Hubble to search its future path. Looking for anything, a rock, an asteroid, a comet, that New Horizons could visit after Pluto. It was like searching for a specific grain of sand on a beach from orbit at night. June 2014. They found something, a tiny object, designated 2014 MU69, later named Arrokoth, only 36 kilometers long, shaped like a peanut, 1.6 billion kilometers beyond Pluto. But reaching it would require burning precious fuel. Every drop spent meant less ability to adjust course later. The margin for error? Zero. October through November 2015. 4 engine burns, each just a few meters per second. Together, they bent New Horizons' path by just 0.1 degrees. That's like hitting a golf ball in New York and landing it in a specific cup in Los Angeles. 3 years later, while Earth celebrated New Year 2019, New Horizons approached Arrokoth. The first images were confusing. It looked like 2 objects. Then, as it got closer, a cosmic snowman. 2 spheres gently touching. The team nicknamed it Ultima Thule before its official name. But this wasn't cute. It was revolutionary. The surface was smooth. Barely any craters. The color of red wine. This showed how planets are born, not in violent crashes, but in delicate waltzes. 2 objects orbiting each other, gradually spiraling together over millions of years until they kiss. After Arrokoth, there were no more targets. The Kuiper Belt is vast but sparse. Finding another reachable object was impossible. So New Horizons kept going, deeper into the darkness. And that's when things got weird. You see, our sun creates a bubble in space. The solar wind, charged particles streaming outward at 400 kilometers per second, inflates this bubble like a cosmic balloon. The Voyager probes cross the edge of this bubble, but they're like 2 people describing an elephant while blindfolded. Each touched a different part. New Horizons is taking a third path, with instruments 30 years more advanced. And it's seeing things that don't match our models at all. In 2021, scientists tried something audacious. They pointed New Horizons cameras at absolutely nothing. Empty space. the darkest patches of sky they could find. Then they did cosmic arithmetic. Subtract the light from every known star. Subtract every visible galaxy. Subtract the zodiacal light from dust in our solar system. Something was still glowing. Led researcher Todd Lauer. We checked our math 50 times. The universe is twice as bright as it should be. Imagine walking into a room, counting every light bulb, adding up their brightness, and realizing the room is somehow twice as bright as those bulbs can produce. Where's this light coming from? Unknown galaxies too faint to see? Decaying dark matter? Something else entirely? New Horizons is perfect for solving this. It's far from the zodiacal light that blinds telescopes near Earth. It's humanity's clearest view of true darkness. But the light mystery is just the beginning. New Horizons is measuring the solar wind as it weakens with distance. And it's not fading smoothly. It's pulsing, clumping, like the edge of our solar system is breathing. The spacecraft's dust counter is registering more hits than expected. Tiny grains, probably from ancient Kuiper Belt collisions, creating a haze we never knew existed. Even stranger, it's detecting pickup ions, particles from interstellar space that get caught in our sun's magnetic field. But they're appearing earlier and in different quantities than predicted. This suggests the heliosphere isn't shaped like we thought. Instead of a sphere, it might be elongated like a croissant, or compressed on one side like a dented basketball. Where Voyager saw one thing, New Horizons sees another. It's like three blind people describing an elephant, and none of their descriptions match, but time is running out. New Horizons runs on plutonium-238. Every year, radioactive decay steals 4 watts of power. Right now, it's operating on 157 watts. By 2030, that drops to 130. Below 120, instruments start shutting down forever. First to go the camera, then the particle detectors. Finally, around 2038, even the radio falls silent. The team has shrunk from 200 to just 40 people, but they're squeezing every bit of science from this dying spacecraft. Alice Bowman. Every morning I check if we still have signal. Every morning I'm grateful we do, but I know that one day we won't. Just last month, they detected something new. The cosmic ray flux is increasing, but not uniformly. It's like the boundary of our solar system has weather patterns. This data is already reshaping future missions. NASA's interstellar probe, planned for the 2030s, is being designed based on New Horizons discoveries. But that excess light? It might be the biggest discovery of all. If we're missing half the light in the universe, what else are we missing? Some scientists theorize it could be from decaying dark matter. Others suggest vast clouds of rogue planets between galaxies. The truth is, we don't know. And that's what makes this so exciting. A spacecraft built to photograph one world has revealed that we don't understand our universe as well as we thought. Right now, today, New Horizons is still out there. Still measuring, still surprising us. A mission planned for 9.5 years has lasted 18. A probe designed to see Pluto has shown us the edge of everything. In 10 years, maybe less, it will fall silent. But its legacy is already secure. It turned Pluto from a point of light into a world with a beating heart. It showed us how planets are born. It revealed that space itself glows with mysterious light. And it proved that sometimes the best discoveries come from refusing to turn off the lights. So what's the takeaway? A piano-sized machine, built by humans, is right now sailing through the cosmic twilight, sending back data that challenges our understanding of reality itself. The question isn't whether New Horizons will eventually fall silent. It will. The question is, what will we discover with the time we have left? And perhaps more importantly, what will we dare to build next? If this story of human ingenuity and cosmic mystery fascinated you, subscribe for more deep dives into the missions pushing the boundaries of human knowledge. Because somewhere out there, 8.8 billion kilometers away, a small piece of human ambition is still exploring, still questioning, still refusing to go gentle into that good night. And in the end, isn't that what makes us human? The refusal to stop asking what's out there, even when the darkness seems infinite and our time is running out.